Circle is the topic for the day. To come with introduction, what is a circle? We have come across the word circle in many circumstances in real life. A circular wheel, which we talk about, a circular ring is what we have many instances where we have a circular shape. Now we all know that a circle is a round shaped figure. So this is how a circle looks. But how do we define mathematically a circle in a more mathematical sense? Now comes the question here that if I take this is circular, or this is a circle which I have drawn on the board. So what makes me call this as a circle, and why is it taken as a special case in its respective discussion, is the biggest question out here. Now circle has many properties which we come across, which we'll be studying in future, but now let's see what exactly is the mathematical definition of a circle. Now let's see the mathematical definition of a circle. Now imagine I have a circular wheel. Now this is a circular wheel. Now we know that this wheel has all its spokes which are equal in length. So if I take a bullock cart wheel, then in this case I clearly see that each of the sticks which are attached to the end points of the rim of the wheel are equal, that is, they are equidistant, which makes me understand that in order for a perfect circle to be formed, the distance from center to each of the edges of the circle must be same, which is a real life example of a bullock cart wheel which we have seen. So therefore this concept of a wheel having equal sticks from the center to the rim of the wheel is what defines the equation, or defines the circle in the mathematical sense. So the same bullock cart wheel which I take in the form of defining a circle, I say that the set of points in a plane which are equidistant from a fixed point. That is, if I take this as the fixed point, then each of the points on the rim are equidistant, as can be seen out here. Therefore, any point I take from the fixed point to this, to this, to this, or this are equidistant. Therefore, in the mathematical sense, I define a circle as the set of points in a plane which are equidistant from a fixed point, which is called the center of the circle. So defining is set of points equidistant from a fixed point is what I define a circle. So in mathematical sense, a circle is the set of points in a plane equidistant from a fixed point, as can be seen here with a more real life example of a bullock cart wheel. And the fixed point is called the center, and equidistant, the distance, is called the radius. The two important concepts of a circle are center and radius, which are defined from the mathematical definition of a circle. Now, therefore, for a circle with a fixed point which is equidistant to any of the rim or the circumference of circle, this fixed point is called center of circle, and the distance is called radius of circle, which comes out to be this. So the center is the fixed point here, and the distance here is called radius of circle. Therefore, center and radius define a circle in the mathematical sense of understanding, as can be seen here. Now let's see how we can derive for equation of a circle. Now let's see the equation of a circle. Now that we have defined a circle in the mathematical sense, the next question which comes is, what will be the equation of a circle? As for example, if I take x-axis, y-axis and origin, I take a straight line, then I know that this straight line has the equation y equals mx plus c, is how we understand. Now similarly, when I take x, y and this, if I take a parabola, then I know that this has a parabolic equation y equal to x squared. So different shapes have different equations, like a straight line is given by this equation and a parabola is given by this equation. Now comes the biggest question: if I have a circle which is in the form of this, then what will be the equation of this circle is the biggest question out here. So we are going to discuss now on what would be the equation of circle in xy coordinate system in its different form. Now let's see the standard form of equation of circle. Initially, what is the standard form? If I take the circle with center as origin, then we call that as a circle in standard form. That is, if I have an xy coordinate system where the circle is exactly at the center of the origin, then in this case, if my radius is r, then in this case a circle with center as origin and radius as some r is given by the equation of circle is given by x squared plus y squared equals r squared. Is called standard form of equation of circle. So this called the standard form, where if I have a circle with center as origin and radius as r, then equation of circle is given by x squared plus y squared equal to r squared, the standard form of circle. Now let's see one of an example problem supporting the standard form of equation of circle. Say for example, I have a problem which says find the equation of circle whose center is origin and the radius is 3 units, is the question out here. So for the problem which says find the equation of circle whose center is origin and the radius is 3 units, then I clearly understand this problem related to the standard form, because standard form of circle has its center at origin and with radius r. Therefore, for the circle whose center is origin, that is 0, 0 in xy coordinate system, and radius which is 3 units, using these two, I have the equation of, I have the circle which is like this: x-axis, y-axis, and this with center origin and radius 3 units. Now let's find equation of this circle where the center is origin and the radius is 3 units. We know that equation of circle with center origin and radius r is given by x square plus y square equals r square. That implies my r, which is 3, gives me x square plus y square equals 3 square. That implies x square plus y square equal to 9 is the answer. Therefore, when I just substitute the radius in the standard equation x square plus y square equal to r square, then I get the equation of circle in standard form, and here being x square plus y square equals 9. So therefore, equation of circle whose center is origin and radius is 3 units is x square plus y square equal to 9, the standard form of the circle. Now let's see the equation of circle with center as hk, that is when the center is not origin. Therefore, for this circle with center as non-origin, let's see what would be the equation of that circle in the non-standard form. So for example, if I have x-axis, y-axis, origin, when I have a circle with center hk, so with center hk and radius r is given by the equation x minus h whole square plus y minus k whole square is equal to r square. So this is how we define the equation of a circle with center hk and of course radius r. X minus h whole square plus y minus k whole square equal to r square. Let's see an example problem to support equation of circle with center hk. So for example, I have a problem which says find the equation of circle with center 2, 3 and radius equals 5 units. So in this case, I clearly have the center which is non-origin, that is 2, 3, and my radius is 5 units. Therefore, when my center is 2, 3, that implies clearly my h is this and my k is this. So h is 2 and k is 3, the x coordinate being h and the y coordinate being k. H equals 2 and k equals 3, and my radius is 5 units. Implies r equal to 5. Therefore, for equation of circle where the center is 2, 3 and the radius is 5, I have the equation given by x minus h whole square plus y minus k whole square equals r square. And then using this, I have h, k and r, which I am going to substitute in the equation. That implies my h is 2, therefore this is x minus 2 whole square, and my k is equal to 3, therefore it is y minus 3 whole square, that is equal to 5 square, which is the radius. Now this gives me x minus 2 whole square plus y minus 3 whole square equals 25, is what is the equation of circle when I do it with the formula. But we need to understand that this can be further simplified to a more simplified answer. Now this equation which is obtained, I would like to further simplify using a minus b whole square for each of these cases. That is, when I have x minus 2 whole square plus y minus 3 whole square equal to 25, then in this case I have this simplified as a square minus 2ab plus b square, and this again is a minus b whole square, so a square minus 2ab plus b square equals 25, which on further simplification gives me, therefore I have x squared plus y square minus 4x minus 6y plus 4 plus 9, which is 13 minus 25 equal to 0. This on final simplification gives me x squared plus y squared minus 4x minus 6y 7 12 equals 0. Is how I get the most simplified equation of a circle with center 2, 3 and radius 5 units. This is how we obtain in the most simplified form. Now let's see the equation of circle in general form. In the more meaningful form of the general understanding of equation of circle is when I take it in its general form. So let's see the general form of equation of circle. So here the circle with the standard equation generally denoted by S, given by x squared plus y squared plus 2gx plus 2fy plus c equal to 0, is called the general equation of circle. And here the center of this circle will be, center is minus g minus f, and radius is root of g squared plus f squared minus c. So these are the two basic formulae I have for the general equation. So for the equation of circle in general form as x squared plus y squared plus 2gx plus 2fy plus c equal to 0, the center of this circle is minus g minus f and the radius is root g squared plus f squared minus c, is how we understand. And it's very important to note that since radius is root of g squared plus f squared minus c and root is defined only for a positive value, at the most for 0, therefore radius equal to positive square root of g squared plus f squared minus c makes me understand that I derive a very important note, because anything inside the root must be greater than or equal to 0. G squared plus f squared minus c must be greater than or equal to 0 for an equation to define a circle. This is very important. G squared plus f squared minus c must be greater than or equal to 0. So now that we have defined the general form of equation of circle, let's take an example problem to understand the concept more better. Say for example, I have a problem which says find the center and radius of the circle, which is given by the equation 3x square plus 3y square minus 6x plus 4y minus 4 equal to 0. So I have a circle whose equation is given by 3x squared plus 3y squared minus 6x plus 4y minus 4 equal to 0. and the question is to find the center and radius of that circle. So let's see how we can do this problem using the general form of equation of circle. So in this case, if I have clearly, when this equation is compared with the standard form x squared plus y squared plus 2gx plus 2fy plus c equal to 0, which is the general form of equation of circle, I clearly see that this coefficients do not match. Therefore, in order to reduce this into the general form, I need to eliminate 3 from x squared and y squared. So therefore, in order to eliminate 3 as the coefficients of x squared and y squared, I divide the whole equation by 3, so that this, when divided by 3, gives me x squared plus y squared minus 2x plus 4 by 3y minus 4 by 3 equals 0 by 3, which is 0. So this is the equation of circle in general form. Of equation of circle. Now from this I am going to extract the center and radius. Now we all know that the center of the standard form is given by minus g minus f, and the radius is given by root of g squared plus f squared minus c. So in order to find the center and radius as required in the question, I need to find g, f and c from this. So let's see what is g. Now when I compare this with this equation, the coefficient of x, which is 2g, is coefficient of x, which is minus 2. Therefore 2g must be equal to minus 2. So comparing, I get 2g equals minus 2, and my 2f, which is coefficient of y, must be equal to 4 by 3, which is coefficient of y here. So therefore 2f must be equals to 4 by 3, and my constant, which is c here, and the constant, which is minus 4 over 3, must be equal. So I get c equals minus 4 over 3, from which I get g, f and c. So therefore when I simplify, I get g equals minus 1, f equals 2 over 3, cancelling this with this and this with this, and my c is minus 4 over 3. So these are the three values which I'm going to substitute in the formula for center and radius, where I get the center and the radius. Therefore I have my g, which is minus 1, f, which is 2 over 3, and my c, which is minus 4 over 3. So with g, f and c, I would like to find the center. Initially my center, which is minus g minus f, is given as minus g and minus f, that is 1 and minus 2 over 3 is the center for the given circle. And next is finding the radius, where I need to find with the formula root of g squared plus f squared minus c, that is g squared plus f squared minus c is what we get. So this, on further simplification, gives root of 1 plus 4 by 9 plus 4 by 3, which on LCM gives on root whole of 9 and 9 plus 4 plus 12, that is 4 times of 3, which is the LCM. So this comes as 25 by 9 which is 5 over 3 is the radius, and 1 minus 2 over 3 is the center. So the center and radius of the circle in general form is how we obtain using the two basic formulae, this and this. Unit circle is one of the type of circle which we're going to discuss now. So what do we mean by unit circle? The word unit means 1, indicates to 1. Therefore, I understand that a unit circle is a circle with radius 1 unit. So therefore, if the radius is 1 unit, then that circle is called unit circle. Say for example, if I take a circle with center as origin and the radius is 1 unit, then in this case of radius being 1 unit and center as origin, I have my equation of circle given by x squared plus y squared equal to 1 is called the equation of unit circle with center as origin. With center origin is how we understand the unit circle x squared plus y squared equal to 1. Now next is the point circle. So what do you mean by a point circle? Before we discuss about the point circle, let's come with a revisit on circles. Now as I see, a circle with radius r is reducing to a smaller circle with smaller radius r2, and then again reducing to a more further smaller circle, say with radius r3, and so on and so forth. It reduces almost, when it reduces with radius, it almost diminishes to reduce to one single point. So this bigger circle has become smaller with reducing of radius, and more reduction of radius, more smaller circle, more smaller and more smaller. Finally, we end up with a point when the radius is almost 0. Therefore, radius equals to 0 units implies the circle is called point circle, because when the radius is 0, the circle diminishes to a point. Therefore, for this radius equal to 0, we call this as a point circle. Is how we understand in mathematics. Therefore, in order to define a point circle is a circle with radius equals 0 units. Is how we understand. So what is the equation of point circle with center origin? Say I want to find point circle with center 0, 0 is given by x squared plus y squared equals 0. There is no constant out there. Is how we understand this. Now, interestingly, in this case that we have defined the point circle is the point itself, we can also say that the point itself is the circle and the point itself is the center of the circle. So, here I conclude that point circle is the point itself, or it is the center itself. Is how we understand with radius equal to 0. Now what happens if I take my center as hk? If my center is hk, that implies my point circle is given by equation x minus h whole squared plus y minus k whole squared equal to 0 square is what we get as the point circle with a center h, k. For example, I have a circle, say x squared plus y squared minus 4x minus 6y plus 13 equal to 0. Then in this case, let's see if this is a point circle. Now in this case, I clearly have my g is minus 2 and my f is minus 3 and my c is 13 as compared with x squared plus y squared plus 2gx plus 2fy plus c equal to 0. Now in this case, the radius, which is given by the formula root of g squared plus f squared minus c, is g squared plus f squared minus c, which on simplification gives 4 plus 9 minus 13, which is equal to 0. Therefore, radius equal to 0, and this is called point circle. Now this with radius 0 implies the circle is a point circle, a circle with radius equal to 0 units reduces to a point, and that point is called a point circle with least radius. Now let's see the equation of circle passing through origin. Say I have a circle which is passing through origin. If this circle is passing through origin, then we have equation of this circle as s x squared plus y squared plus 2gx plus 2fy equal to 0. Now this makes us understand that whenever a circle passes through origin, the c will be equal to 0. So the constant c in the general equation of circle is vanishing, because when a circle passes through origin, we have c equal to 0 always, and therefore the equation is x squared plus y squared plus 2gx plus 2fy equal to 0. The next case here is where the circle is exactly with its center on x-axis. So what would be the equation of circle with center on x-axis? Say I have my x-axis, my y-axis, and with center on x-axis. Let's see if my y coordinate would be 0, because when the center is minus g minus f, the f reduces to 0, and therefore when center is on x-axis, minus f equal to 0, that implies f is 0, and therefore with this f equal to 0, I get my equation of circle as x squared plus y squared plus 2gx plus 2fy, which vanishes because f is 0, and therefore I get equation of circle with center on x-axis is s equals x squared plus y squared plus 2gx plus c equal to 0. Similarly, let's see what would be the equation of circle with center on y-axis. Now in this case, I have my x, my y-axis, my origin here, and the circle is exactly with its center on y-axis, therefore its x-coordinate is 0, therefore minus g minus f reduces to 0 comma minus f, and therefore we have here minus g equal to 0, that implies g equal to 0, which defines the equation of circle where s is x square plus y square plus 2fy plus c equal to 0. G equal to 0, therefore 2gx, the whole term vanishes because g is 0, will be the equation of circle with center on y-axis. Is how we understand the special cases of the circle with center on x-axis and center on y-axis with the respective equations derived. Concentric circles. What do we mean by concentric circles? The circles which have the same center are called concentric circles. Say for example, I have a circle with center this. I have one more circle with same center. I have another circle which is of the same center, and so on and so forth. So each of these are said to be concentric because they have the same center. That's how we understand the concentric circles. Now here, let me say the equation of this circle is S is x square plus y square plus 2gx plus 2fy plus c equal to 0. Then the equation of any other concentric circle, say for this, will be, say I take this which is concentric with this, is 1, 3 and 4. So the circle 3 which is concentric with this is given by s dash, that is x square plus y square plus 2gx 2fy plus c dash equal to 0. So when two circles are concentric, they differ only with the constant. The rest of them are same because the center does not change. The center being minus g minus f is fixed for any circle which is concentric. The only thing which changes is the constant c, and hence when two circles are concentric, they have only the constants which are different. G and f is the same. That's how we understand the two circles being concentric to each other. Now for the circle, we have x-intercept and y-intercept. Just like a straight line has x-intercept and the y-intercept when taken in xy coordinate system, similarly a circle which cuts x-axis makes an intercept which is called x-intercept, or a circle if it cuts y-axis makes a y-intercept, is how we understand. Therefore, let's see how we can find the x-intercept for a circle. So for example, I have a circle say this. Now here, this circle with center as minus g minus f is cutting the x-axis at 2 points A and B. Now this is called the x-intercept of this. Say my circle is x squared plus y squared plus 2gx plus 2fy plus c equal to 0 in its general form. Then x-intercept is clearly the distance AB, which is given by 2 root g square minus c units. That's how we understand the x-intercept, which is 2 root g square minus c units. Similarly, we have the y-intercepts, which are going to discuss in the next section. Similarly, let's see what would be the y-intercept for the circle. So for example, I take x-axis, y-axis and origin where my center is minus g minus f, and it is making an intercept on y-axis, which is this. So let's see, for an equation of circle which is in general form as equal to 0, I have the y-intercept, which is given by the distance AB, which is nothing but 2 root f square minus c units, is how we understand the y-intercept made by the circle on y-axis and the x-intercept also made by the circle on x-axis. The x-intercept and y-intercept have their own respective formulae. So let's take a special case where a circle touches x-axis. Then under the condition, let's see where I have x-axis and y-axis and where the circle is touching x-axis, where the center is minus g minus f and it is touching here at on x-axis at P. Now clearly I see that the coordinates of P are minus g comma 0 because the distance which it makes here is same as what it makes here. So x coordinate is minus g comma 0 is the point where the circle is touching x-axis. So when a circle touches x-axis, then we have the condition this, which is obtained from the intercept, because my intercept is 2 root g square minus c, which reduces to 0 when this tends to touch, and this on simplification gives this equal to this. This is how we obtain the condition for touching the circle touching x-axis, g square equal to c when the circle touches x-axis. Similarly, let's see what happens when the circle touches y-axis. That is, if I have my x-axis, my y-axis and origin where the circle is touching y-axis here, then in this case I have clearly 2 root f square minus c, which is the y-intercept, tends to 0 because this touches only when the intercept reduces to 0 dimension. So this gives me this equal to 0 where my f square equal to c is the condition when the circle touches y-axis. Touching x-axis, g square equal to c, and touching y-axis, f square equal to c. Secant of a circle. So what do we mean by secant of a circle is what we're going to discuss in the session. Say for example, I have a circle in the xy coordinate system. Now there's a line which cuts the circle. There's a ray which cuts the circle at points A and B. Now L is called the secant of the circle because the line which cuts this circle is called secant. So this is called secant for the circle as considered here. So we need to understand that when a circle cuts, it always cuts at 2 points at the most, and therefore when a secant exists for a circle, there are 2 points which are the points of intersection of the secant and the circle. Here A and B are the points of intersection, and this gives a line segment which we're going to discuss with a new property in the continued session. A secant is the line which cuts the circle, any given circle, is how we understand. Now, as we have taken in the previous session about xy coordinate system and a circle, now a secant is a line or a ray which cuts the circle, passes through circle at 2 points. Now, that 2 points which make a length, say I have AB, which is formed when this is extended up to here. This distance is called the chord. Here AB is called the chord of the circle, and the whole of AB when extended is called secant of the circle, is how we understand the difference between the line segment AB, which is the chord, and the ray AB given by arrows as the secant of the circle. The chord is the part of the secant, is how we understand the difference between chord and secant of circle. Now suppose I have a circle with center and the diameter as AB, and the coordinates of A are x1, y1, and coordinates of B are x2, y2 in xy coordinate system. Then in this case, the equation of circle with diameter extremities, that is what with the endpoints given for the diameter, I can derive the equation of circle as x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals 0, is the equation of circle with extremities x1, y1 and x2, y2. Now let's see the next concept of finding the equation of circle which passes through 3 points without any conditions out there. The only condition is that a circle passing through 3 points, I want to find the equation just by utilizing the 3 points as given out there. So let's see how we can find the equation of circle using the 3 points given. So for example, I have a circle which passes through 3 points, say A, which is 1, 1, and B, which is 2, minus 1, and C, which is 3, 2. So if I have the circle which is passing through 3 points A, B, and C, then let's see how we can find the equation of circle. Now we all know that the general equation of a circle is given by x squared plus y squared plus 2gx plus 2fy plus c equal to 0. So using this general equation, now the first point A equals 1, 1 implies this must substitute or satisfy the given equation of circle, because A11 lies on the circle. That means this belongs to S, implies x squared plus y squared plus 2gx plus 2fy plus c equal to 0. That implies I get 2g plus 2f plus c equals 0. So using the point A which lies on the circle, it satisfies this. Therefore, I get the first equation given by this. Similarly, my point B belongs to S implies I get this to be x squared, which is 2 squared plus y squared 2gx plus 2fy plus c equal to 0. Thus, on simplification gives 4g minus 2f plus c equals 4 plus 1, which is minus 5, as equation 2 is what we get for this. Now, thirdly, the third point lying on S also gives me the third equation. So let's see how we get the third equation. C equals 3, 2 belongs to S implies S equals x squared plus y squared plus 2gx plus 2fy plus c equals 0. Therefore, this on simplification gives 6g plus 4f plus c equals 9 plus 4, 13, which is minus 13. Therefore, I have three equations which I have to simplify using the elimination method or the substitution method. So therefore, continued from here, I have my three equations which are obtained from each of the points A, B and C. Now I need to solve these three equations to find the three unknowns G, F and C using the elimination method of simultaneous solving. So in this case, I first take equation 1 and 2, which gives 2g plus 2f plus c equals minus 2 and 4g minus 2f plus c equals minus 5. Then I subtract the two equations, which gives me both f get cancelled, and I get this to be minus 2g, or not this, this gets cancelled, and I get this to be 4f equals 5 minus 2, which is 3, is what I get as equation 4. And this is obtained by doing 1 minus 2. Similarly, I'll take equation 2 and 3 and I subtract. So equation 2 minus 3 would give me, on subtraction, 4g minus 2f plus c equals minus 5, and my equation 3, which is 6g plus 4f plus c equals minus 3, on subtraction gives minus 2g minus 6f equals minus 2 is what we get for equation 5. Now I just consider equation 4 and 5 and I try to eliminate either g or f. So let's see how that is possible. Now let's consider equation 4 and equation 5, which needs to be further simplified. So now that in the previous session I have obtained equation 4 and 5 from these three equations 1, 2 and 3, I got my equation 4, which is minus 2g plus 4f equals 3, and minus 2g minus 6f equals minus 2. So let's eliminate g because their coefficients are equal. So it is always right that I eliminate that unknown whose coefficients are same, or we make the coefficients same to eliminate one of the unknowns. This is how we understand the elimination method. So therefore here, when I subtract 4 minus 5, I get plus, 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 and this gets cancelled, and I get 6f plus 4f, which is 10f that is equal to 3 plus 2, which is 5. Therefore, my f is 5 over 10, that is 1 over 2. So f is 1 over 2, which on substitution gives me g. Therefore, f equal to 1 by 2 implies minus 2g plus 4f equal 3 is what I get from equation 4. From equation 4, I substitute f equal to 4. Therefore, this on reducing gives me minus 2g, 2 1s, 2 2s plus 2 equals 3. That is minus 2g is 3 minus 2, which is 1. That implies g is minus 1 over 2 and f is 1 over 2. And then substituting these two in one of the equations gives me c. So let's see how we can find even the third unknown c using the elimination method. So therefore, with the equations where I obtain f is half and g is minus half, I use these two unknowns and I substitute in equation 1. I get 2g, which is 2 times minus half, plus 2f, which is 2 times of 1 by 2, plus c equals negative 2. 2g plus 2f plus c equals 2. This on further simplification gives minus 1 plus 1 plus c equals minus 2, which on simplification gives c equals minus 2. Therefore, f is half, g is minus half, and c is minus 2, through which I am going to find the equation of the required circle passing through the 3 points A, B, and C. Therefore, the 3 unknowns are found to be g equals minus half, f equals half, and c equals minus 2, which I am going to substitute in x squared plus y squared plus 2gx plus 2fy plus c equal to 0, which on substitution gives me x squared plus y squared plus 2gx plus 2fy plus c equals 0, which on further simplification through LCM gives me 2x squared plus 2y squared minus x plus y minus 4 equals 0 is the equation of a circle which passes through the 3 points (1, 1), 2, minus 1, and 3, 2. Is how we can find the equation of the circle which is passing through 3 distinct points on the circle, and hence its equation in general form. Next is parametric equations of a circle. So what do we mean by parametric equations? Representing in the form of angle and radius is what is the parametric equation. So let's see how a circle can be represented in the parametric form. Initially, to start with, let's take a circle whose center is HK and whose radius is R. And let me say this makes an angle theta out here. The angle is theta. Now with this, with an angle theta made in the clockwise anti-clockwise direction of the radius from a suitable point P, then in this case we know that since the center is hk and the radius is r, we have the equation of circle given by x minus h whole square plus y minus k whole square equals r square. Is the equation of circle N with center hk and radius r. Now the parametric equations for this circle are said to be when I take my x minus h is r cos theta and my y minus k is r sin theta, because when I substitute these two, I reduce to the identity cos square theta plus sin square theta, which is 1, and I get the left hand side identically equal to the right hand side. So with this, I have the parametric equations where one is x equals h plus r cos theta and y as k plus r sin theta, which are called the parametric equations of the circle with center hk and radius r. The parametric equations connected with equation of circle involves radius and angle, the angle theta out here. Also, it is important to note that theta lies between 0 and 2 pi, one full rotation of the circle being 360 degrees, so theta lies between 0 and 2 pi. So for example, I have a circle whose center is origin and radius is r. Then in this case, I have the parametric equations given as x equals r cos theta and y equals r sin theta. Is how we understand the parametric equations, because h and k are zeros. When I substitute, the formula reduces to x equals r cos theta and y equals r sin theta, with 0 less than or equal to theta less than or equal to 2 pi. Similarly, if I have a circle with center origin and radius is 1, where this is called unit circle, then in this case I have x equals cos theta and y equals sin theta, because r is equal to 1, reduces to x cos theta and y sin theta, with 0 less than or equal to theta less than or equal to 2 pi. So the different cases have the different parametric equations of the circle connecting with radius and the angle theta. Now let's take one example problem to understand the parametric equations of a circle more better. To start with the problem, if my question says find the parametric equations of the circle x squared plus y squared plus 6x plus 8y minus 96 equal to 0, then let's see how we can find the parametric equations of this circle using the concepts learnt in the previous session. Now, as I clearly have the circle given by x squared plus y squared plus 6x plus 8y minus 96 equal to 0, then my center C is clearly given by minus g minus f, where my g is 3, f is 4, and my c is negative 96 from the circle. Therefore, center being minus g minus f gives me minus 3 minus 4 as the center, and my radius r is given by root of g squared plus f square minus c, which gives me root of g squared plus f squared minus c. This gives me root 121, which is 11. This is how we obtain the center and radius. Therefore, my center is minus 3 minus 4 and my radius is 11. Now center, when I compare with h and k, my h is minus 3 and my k is minus 4. Therefore, the parametric equations are given by of circle are given by x equals h plus r cos theta and y equals k plus r sin theta, where I substitute h, k and r and then I get the parametric equations. So therefore, let's see how we get with x equals h minus 3 plus 11 cos theta and y is k plus 11 sin theta are the parametric equations for the circle with 0 less than or equal theta less than or equal 2 pi is what we get here.